Here we are, Geometry Friends, the final section of section 13. I know I don't like to have 3 videos of one particular section, but that's okay. Here we are, we're going to knock it out. We're going to talk about combinations. Combinations of indistinct objects is when order doesn't matter. So I want you to go back to the scenario where we have 15 students in class total, right? And I want to choose 3 students. And I want to know the possibility of having these 3 students chosen. So in a sense, the whole possibility, the whole like total number of options would be 15 times 14 times 13. So I'd have 15 choices for the first person, I pick 14 choices for the second person, and 13 for the third. This gives me every possible way. So imagine 15 students at cheer, and I'm choosing from them, and you 3 students, my 3 baby girls are involved in it. So I've got Zoe, Eva, and Charlie. So check this out. That would be Zoe, Eva, Charlie. That will be one possibility out of my 15 times 14 times 13. But another possibility would be Eva, Charlie, Zoe. Another possibility would be Eva, Zoe, then Charlie. Another possibility. So these are all distinct things. How many of these are there? There's 3 factorial different ways to arrange these 3 young ladies, right, in the choice of me choosing them. So there's 3 factorial different circumstances that can happen. I don't need to consider that if I'm not considering you guys for first, second, and third, like some distinguished place. If I'm just choosing 3 students out of 15, I don't need to consider all of these repeats. You got me? And so that's where R factorial, dividing out R factorial comes in, because when we have a permutation, order matters. I want all these repeats in there. So remember, permutation was n choose r, where order matters. So it was n factorial over n minus r factorial, right? And that's what will get us our 15 times 14 times 13, right? In that scenario that I'm making up. Now, when we think about combinations, when I flip the script and I talk about combinations, because I don't really care about the repeat, I'm going to have to divide out all the repeated values, which in this case is 3 factorial, but which in general would be R factorial. Take a moment to let that sink in. I know you can just memorize the formula and go through and do the problems, and that's fine, but there's something very helpful to understand why your combinations, where order doesn't matter, is actually going to be less choices, less distinct choices. There's something to understand in that, especially when you see this again. All right, so this is our final example of the section. Yay! All right, so for her invitations, Monica can invite 6 of her 20 friends to join her at the theme park. If she chooses to invite friends at random, what is the probability that she's going to invite 3 distinct people: Tessa, Guido, Brendan, Faith, Charlotte, and Rihanna? Okay, so let's see how we can do that. So this really is 20 people choose 6 people, and so it's a combination, because it doesn't matter if I choose Guido first and then Charlotte second and Rihanna, or if I choose them in this, or it doesn't matter the order. So in this situation, this is not my probability, but this is the sample size that I'm using. So the sample size that I'm talking about is going to be it's going to be given as n factorial. I'm writing this wrong. The sample size, I'm going to put this whole thing in the denominator, but the sample size that I'm talking about is going to be n factorial, right, divided by n minus r factorial, divided by r factorial. And I don't know why this looks so crazy, but you guys are with me. Okay, so that's just coming straight out of the formula that we have. And so that would be 20 factorial divided by n minus r. That's going to be 14 factorial divided by 6 factorial. So technically, if we plug this in the calculator, we're going to get 38,760 different ways different possibilities without the repeats of any group of students, right? Without the repeats of any group of 6 students. So these are all the possible ways that I can grab 6 students out of the class of 20. And now what I'm going to do is say there's only one group that I want, and that's my 6 friends or whatever. And I have 38,000, one out of 38,760. I have to tell you, I really do love these types of problems and I like thinking about it, but I am sad that I'm not able to talk to you about it face to face. Because there is something about face-to-face teaching that's not just exciting, but it also helps me gauge better what you understand, and you can ask quick questions directly of me. Please, please, please don't hesitate to ask questions about this or any lesson. And thank you guys for being patient and going through the 3 lessons. I hope you watched them all at the same time, but whatever. Let me know if you have any questions. I look forward to talking to you very, very soon. Peace, guys.